Hello, Marauders. I'm on the moon again. I found this strange little moon creature here. But anyway, hopefully you're having fun with the videos. Today, we're going to do day 3. And in the video, I'll tell you which question to submit so I can give you credit. Today, you're going to be looking at some shadows and also trying to follow and give directions. It's good to have someone around the house to help you out with doing this with a partner. All right, so welcome to day 3. And this is section 7.03. And it says, it is often important to describe shape and other spatial information accurately with words. You can describe a shape in many ways. Some shapes have special names, like circle. May not be enough to describe a shape. When a shape looks like another shape that has a special name, you may use extra words to describe the original shape. You may say it looks like an upside down L, or like a house lying on its side, or saddle shape when you're trying to describe it. Often, you may not know the shape of a figure or a solid. A solid means something three-dimensional, like a block, or a cylinder, or a prism. You must determine the shape from a set of features. Scientists face this situation when they just try to deduce the shape of a molecule from what they know about the atoms that form the molecule, or from how the molecule scatters light or X-rays. Sometimes describing how a picture looks is not as helpful as describing how to draw it. For example, suppose you give someone traveling directions. You would more likely say to walk 2 blocks north, turn left, and walk another block, then describe the path as an upside down L. Yeah, go in an upside down L till you find the 7-Eleven. The recipes, that's what our book says, recipes, used in math are often called algorithms or constructions. They're like directions. You will practice using each of these 3 ways to describe shapes. Let's go to the next page. Okay, next page. But sometimes use names, features, or recipes to describe things. Okay, so this is the triads, and I want you to think about these. Normally I do this in class with a flashlight, but here's what you see. This is number 1 in the triad. So I want you to actually do this problem as homework also. There's some strange object here. And when the light shines this way, it makes a square on the wall. But when the light shines from the top straight down, it makes a circle. What solid might it be? Describe the solid in words. So remember, this is 3-dimensional. It's 3D. That's why we use the word solid as opposed to being flat. So try to name it or draw a picture of it. I'll give you a hint. You probably have this item in your kitchen. It's a very popular object. I'm not going to tell you, but when you watch the next video with the answer to the homework, I will reveal it. Okay, here's number 2. Same thing. The light comes straight down. It makes a round shadow on the ground. When the light shines this way, it makes a triangle. What could it be? Describe it. Maybe it has a name, or try to describe it. Try to draw a picture of it. Use our idea of drawing 3-dimensional objects using the parallel lines. Like if you think it's a Rubik's Cube, remember you would draw a block and then do the parallel line thing, like, okay, parallel, whoops, not parallel, okay, whoops, not long enough, parallel, get them all the same, and then get that a little better. And you notice these will be parallel, these will be parallel, these, and well, that's a block or a cube, or I could call it a square prism, but this isn't the right, I'm trying to write square prism on the screen. That's not the right shape, is it? No, that's not it. But you can draw it or describe it. And once again, the ultimate challenge. What the heck is this? Light coming from each direction. It's a circle. No, it's a triangle. No, from this way, it's a square. This item does exist. Okay, next page. Okay, so here's officially the homework. Okay, so I'm going to guide you through some of these and leave you on your own. Here's a neat little directions, just in case you forget: north, south, west, and east. Remember, think of the map of the United States. We're on the West Coast. California's over here. Often, like sailors might get bored, so they make a fancy compass. And notice they use some geometry. Later in the chapter, we would be actually drawing these things, but we need compasses to do this. And here's even a fancier one. I won't go into these compass directions, but there's north, northeast, east. This is called north by northeast. In other words, you're a little bit north of northeast. Here's northeast, and you're a little bit north of it. This one says east by northeast. In other words, you're a little east of northeast. You won't need to use those fancy directions. Okay, so number one, the homework. You just read these directions, follow them, and then answer these questions. What shape will your path form? Remember, face north. Remember, north's up here. Start drawing like on a piece of paper. I'd use like a pencil. Follow the directions. What shape did you end up with? In what direction will you be facing? Will you be facing north, east, south, or west? And here's something to think about. The direction turn right does not specify how far to turn. I would demonstrate in the class, if I turn right, what if I just start spinning to the right forever and ever? You probably made an assumption that you made a corner, didn't you? You made what we call a right angle, or 90 degrees. You probably did a perfect corner, didn't you? But nobody said when you said turn right, how much. You could have just turned a little bit right. Or you could have turned a lot and kept just turning right, over and over and over. That's number one. So you do this. Number two, okay, you pick a simple shape. Some people pick a letter in the alphabet, but you can pick something like a house, any type of shape you want. Give it a name. Then write the directions, describe it with a recipe. In other words, write out the directions of how to draw it with, write it with paper. Then here's what I want you to do. Give the recipe or the directions to a friend. So normally you do it with a partner in class, but do it with someone around the house. Don't tell them the shape. See if they can draw it. So how well can you write down directions? That'll be fun. And number three, normally in class, I'd take some people's directions and I intentionally try to be kind of silly and follow your directions in a strange way. Number three, it says draw two segments. Okay, do we remember what a segment is? A segment's a piece of a line. Okay, so in other words, there's a segment. Okay, draw two of them. Got it. Oh, that are perpendicular. Now, some people don't understand perpendicular. Those lines are not perpendicular. Perpendicular means the two lines meet at a perfect corner. Often we draw a little box there. So this has to be a perfect corner. We say 90 degrees with a protractor. So just like if you drew a box, this has perpendicular lines. Each one of these is perpendicular. The corners are perfect. Okay, so you need to make two lines that are perpendicular. So no, see, look at that. That's not a perfect corner, is it? Okay, so you got to get the lines perfectly perpendicular, like that. There we go. But the next thing, where they cross, they need to cross at their midpoints. What's a midpoint? That is the middle point. The middle point. In other words, you've got a line, you find the exact middle of it. Here's the middle right there. Okay, so how do people, and when people draw a segment, some people like to put an end point on the end. And then to say that this is exactly the middle, maybe I should get that a little better. What people will do is then put a little mark here, make the same mark to try to say that this piece and this piece are exactly the same length. So you got to try to make your two lines, make them perpendicular, but not like that. Make sure that wherever they cross is they're crossing each other at their midpoints. So after you do that, then connect the four endpoints. What's an endpoint? a point at the end. So here and here. Of course, my drawing's not very good. Mine's intentionally wrong. I'm trying to get a dot right there. Then I want you to connect the end points. Okay. What shape did you make? Is it possible to make more than one shape? That's your question, so you draw it. Once again, when you're done, watch the answers to the homework video and I'll show you the correct answer. Number 4, just follow these directions. You're going to need a ruler. Draw this recipe or directions. Do this one. Compare them. Are they the same? Are they different? Number 5 says a quadrilateral. Quad is 4. This is a shape with 4 sides. And it has horizontal, vertical, and diagonal lines of symmetry. In other words, you could fold the shape with a horizontal line, a vertical line, and a diagonal line, and it'll be perfectly symmetrical. What shape is it? Also, draw a quadrilateral that fits the description. Draw it. Is there only one answer that works, or is there more than one thing you could draw? Lastly, number 6, and this is the one you are going to submit, okay, in the little text entry box, you know, when it gives you the assignment, says type something in. You tell me what 3-dimensional solid, so it's 3-dimensional, it's solid, okay, like a box, okay, or a cube, has a circle as every cross section. And what is a cross section? That means if you sliced it, you know, sliced it right in half, if you went, you know, like Fruit Ninja on it and sliced it, what would you see? And it doesn't matter where you slice it, anywhere you slice it, when you look at it, you go, hey, it's a circle. So when I slice it and look at the inside, it's a circle. What shape is that? And that's the end. Okay, so have fun with the homework. When you're done, check out the video. Don't forget to submit this answer. Even if you're wrong, that's okay. Submit it.